guys, Ash here from Team Outlaws 4x4. Today I just wanted to show you a little bit about BendTech, the software I use to draw the frame on the truck. Just a bit of an overview. I've had a few people ask about the software. If you've got a bender and you plan on making anything half decent, you really need this software. Especially if you want to do repeat bends. I can't stress enough how helpful this software really has been. There's a few different versions of the software, starting down there at EZ, and then you've got EZ3D, Pro, and SE. A lot of it's to do with obviously the capabilities. So you can see down here, if you've got a design which has more than 6 bends in it, you're going to need at least Pro or SE. I started off with Pro actually, and I upgraded to SE. And the main reason for that was, you'll see, as good as BendTech is, it is an absolute pain in the ass to use. It is really clunky, but it does give excellent results. So what I did was I designed the whole frame in BendTech, and then I exported it as a IGS file, and you can't do that unless you've got SE. And once I was able to do that, I exported it into Fusion 360, and once it was in Fusion, then so I did the rest of the fit out on the truck, all the plate works, all the brackets, all the arms, everything like that. That was all done on Fusion, using the model which was designed in BendTech. Okay, so this is BendTech. When you open it up, basically you've got you have your library down the side. Now, what BendTech really does is it turns your bender at home or in your workshop, your manual bender, into basically a CNC bender, where you yourself are the servos, and you're doing the steps or the motions of the tube for the bender. So for all that to work, you need to set up a library, and your library is, we have a tube library, a die library, a tube library, and a machine library, because I've got SE. If you don't have SE, you won't get that option. Obviously, you can set up your spring back. Those of you that's bent before, you'll know that just because you bend the tube through to 90 degrees on the degree wheel doesn't mean it's going to stay there. So as soon as you release the tension off the hydraulics, you're going to get what's called spring back, and it's going to spring back a few degrees, depending on the material you're using, depending on the thickness of the material. All of that is going to make a difference on the amount of spring back, and that is why for each material and each die you can set your spring back. So, and that's done in here. where you've got your achieved and calculated. Right, here we go. So this is a list of the dies that I have on hand. The 4-inch, I don't have a 4-inch die. I don't know why that's in there. So the way I do it when I'm creating a new die is I write the first bit is the tube size it's designed for, the CLR or the centerline radius of that die, and then the material that I'm planning to use for it. Now I do this because when you set up a new die, I'm not going to run through it today, but you run through the wizard where you basically do it the first time you get a new die. You'll set up what you know. You'll enter in all the parameters. You know, say you buy a new 1 3/4 inch die with a 5.5 inch CLR. You'll enter in the parameters, and you might be planning on bending 0.095 inch wall tubing with that, right? And maybe chrome moly tubing, because mild steel tubing is going to be different again. And what you do is you'll enter in all the parameters into the wizard, and the wizard will tell you, go and cut a piece of tube X amount long, measure the tube exact, and then bend it to exactly 90 degrees. Once you've bent it to exactly 90 degrees and you take it out, and you've got to really take your time to get it spot on. You take the piece of tube out. It told you to cut a set length of tube to start with, and it then told you to bend it to 90 degrees. You've done that. It'll then ask you to take some measurements of that tube from each end, and you'll enter in all those measurements, and you basically calibrate the die, and then it saves all the information. So when you go and when you go and do a drawing which is using that die and that material, you can click on that die out of your die library, and you know that the spring back's going to be correct and for that material. So yeah, if you got 1 3/4 inch die, and today you're going to use mild steel, which is 0.095 wall thickness, and tomorrow you're going to use chrome moly, same size steel, but chrome moly and a 0.095 wall thickness, you really should do a second calibration. Like you can see here, I've got two dies, 2 3/4 dies, same CLR, but the material thickness is different. One is the 0.125 inch and one is the 0.095. And the reason for that is, depending on the material that we're using, that will change the amount of spring back calculated, and so it all has a big effect. It's pretty important to set up the program. The better you set the program out, the better results you're going to have. So then you've got a tube library. In here you can add in just about anything you want. You know, you can represent parts. You can so what I've got here, I've got my actual materials that I use when I'm drawing in, and then, you know, I've done some outside of the box thinking here, where I've got like one here called Coil over, and you'll probably find that Coil over is, and all these you can set different colors. You can even set up the weight per inch. Over here you can set whether it's your wall thicknesses and your overall diameter. So for a coilover, see I've got it in here as a 3.75 inch diameter. Yeah, and you can see later on why I've done that on one of my models. Like engine, to represent an engine. So basically all this was before I really was using Fusion 360, and I was trying to get an understanding of the best way I could represent things while I was designing and drawing the frame out. So the best way for me to do that was to, draw a block that was 28.25 inches tall by 24.35 inches long. The thickness didn't really matter because all I was worried about is the overall dimension, and that gave me an engine. But yeah, you'll see. So if I bring up one of my one of my files, you can see it gets a bit messy, a bit hard to look at as well. So there's a few things we can do to make it look a bit easier, but you can make it look even worse by clicking here on the display and going to Y format. So like that, it just looks like a jumbled mess. A lot of tubes, a lot of dots. So each one of these dots in this program, it's called a pick point. And a pick point is basically a spot in space referenced from the absolute zero, or from 0, x, y, z. Now you can turn the pick points off. Here we go. There you go. So I've also got in there's a few dimensions. I've got reference in there for when I was building the frame out. Now you can see the different colored tubes, they actually represent different size tubes or different wall thicknesses. So the light pink tubes you'll find are 1.5 inches, and the purple and dark purple are 1.75 inches. Now, to get to something like this takes a very, very long time. It is very complex, and everyone can definitely do this, but it pays to have notes in front of you and a clear mind with no distractions, because you will be looking at it as you're drawing it like this, and you'll be saying, hey, where the gearbox cross member is, and you'll be going, geez, how do I get in there? And you'll be like going in here, and you'll be like, oh yeah, down in here, I'm gonna draw in a new brace, a new gearbox brace, and how I'd do that is I'd say if I wanted to draw a new gearbox brace from this point to this point over here, right? First of all, I come up here and I select my my material or the tube that I want to put in there. So maybe, you know, for instance sake, we're going to put a 1-inch tube in, okay? And because this is just a straight tube, we're going to say, yeah, we want to put a straight one in, and it automatically goes to our wireframe. And it's as simple as letting it highlight where we want, where the pick point is, right? And we say we want to start here and finish here, okay? And that's it. There's that tube. And it's just put that tube in. If we go back to display, and you can see there's the tube. Now, although it looks like it's nicely notched into this junction, it's actually not at this point. You've got to manually do that. So every tube, every junction point, so if we want to look at this tube that we've just put in here, what we can do is we come up over here to cutting, right? And I will just clear all this cutting that I've got sitting in there. So we want to do a new cut. Click that, new, and we highlight the tube, and look, it comes up with a little note there saying select the feature you wish to cut. So this is the tube. We want to cut this tube. We click it, and it goes green. And we want to cut this tube to this tube, and this tube. Right? And you see how they're all red. And then we come over here and we say complete, and you can see there it's given us the notch. It's notched it, right? And then we'll say we want to do a new cut, and we come to the other side of the tube. I'm going to go this tube, on this tube, and this tube. Complete. And it's notched that one, right? Then what we can do is we can select parts, because every tube is a part. So we can select this part, which is this one here, and it comes up over here. It's this straight tube, right? And from there we can come over to transfer, and we can look at this straight part. Or we can look at part details. Click at part details is what we want. And you can see we've got that, we've pulled that tube out of the assembly. And this is the tube there, and you can rotate the view around, and you can see down here we've got our nice little notches on the end. Okay. Now we can also see that up here it's got a cut length of 711.2 millimeters. I know it's millimeters because before I started this video I set up millimeters. So yeah, what this cut length means is you can go and get your piece of pipe and cut it at exactly 711.2 millimeters, and once you've done that, you can you'll print out. So if I just minimize this and go back to our assembly and go back to cutting. So these are the two cuts for that tube we're looking at, okay? And if I show you what happens, if we click on details, this is the wrap that will print, that you can print out, and Not very, oh, there you go. So this is the wrap, and basically what happens is you'll put this on your tube. You'll wrap it around. You'll line up your red line, and when you cut it out, this will exactly meet this line here. So you'll tape it onto the end of your tube, and this red line here, you will measure from the end. It will be 24.189 millimeters to the end. That's the end of the tube. Okay. At the other end of the tube, over here somewhere, you'll print out your other wrap, and you'll tape that onto your tube, and that will also have a distance to the end, and it will be talking about the end that it's at over here, or it will have this measurement here, which is the distance to the second. And I might be telling you porcupines. It's been a while since I've done one of these. That just does not seem. That seems small enough to be measured from this end. Let me just check to see if we are actually in millimeters. Oh no, see here the unit measurement, so we are in millimeters. Alright. So we open up the, oh there you go. Well, on these straight ones, I actually don't know what that means. Usually, the distance to the end is from this line to the end of the cut pipe, the pipe that you cut. And you slide this on, you line that up with that distance, and then this blue line obviously lines up, where it says lines up with the first mark, it's talking about on your other wrap, lining this wrap up, this blue line with the other line, and that way you'll have your orientation right. But yeah, not a great example. Alright, let's do this. No, I don't want to save that part. So, for instance, let's have a look at this part here. The other thing is you can just go on parts and you can pull a hole. So on my truck, this is one of the hardest parts to bend. It's got 2 compound bends in it, and that's the main lateral bar. So if we pull this part out and we have a look at it, so that's it there. Okay. Now on the main lateral bar, that's all one piece from the front of the truck to the back of the truck. Now you can see up here we need a cut length of 4.292.8 meters. Okay, so that is based on a straight piece of pipe. So you go and cut a straight piece of pipe, that exact length there, and you lay it down. And then what happens is you mark one end of the pipe start, and you mark the other end of the pipe end or finish. Okay, and then you read this section here, and you look at the order, and the order is step 1 and 412.1 millimeters in from the start, which is the start end of your pipe that you've labeled. You put a mark, and that mark will symbolize bend 1. 911 mil in from the start, you put another mark, and that's bend 2. And you go through this all the way till you get to at 3.442.247 millimeters in from the start. You put your last mark, and that's going to be bend 5. Okay, and what happens is you then go and load your tube into your bender, and if you're like me and you've got one with compound bends, when you set it up in your bender, you'll also have to set up a and you should do this anyway, just maintain your bends on the right plane. You should set up an angle finder, preferably a digital one, on the back side of the tube, and you'll set all that up to 0, and you'll pull your tube through your bender to the first mark here, and you'll do a bend to 9 degrees. And once you've done that, you'll pull through to your second mark, but you'll then do a minus 171 degree rotation of the pipe. And minus means you're going to rotate the pipe 171 degrees to the left. And once you've done that on that mark, you'll then bend it 26 degrees. And then you'll pull it through to the third mark, and you'll rotate it a further 180 degrees, and you'll do another 26 degrees, and so forth, and you follow it through. And I can show you what that will look like. And so the other thing is you can come up here and you can click on your part details and bend order, and this is quite a useful tool, and it will help you decide on how you're going to do your bending and make sure that your setup at home or in the workshop, you're not going to end up bending your tube into the floor. So right here, this represents the die. See if we can make this. Oh, there you go. So this represents the die. Okay. And these are our bends. So we've got 5 bends to do. 1, 2, 3, 4, 5. And we can just click play. And you can see that's how it's planning to play out with the current bend order. Now, for some reason, if we just go back to that second last bend there, all that bit's all right. It's that one there. Is it that one? Yeah. See this one here, it's coming down. This is heading down towards the floor. So depending on what height you've got this at, you might find that because this is now bending down, you might find that that's going to hit the floor, and that's not going to work for you. So what you can do is you can flip the We can reverse. So these options here allow you to flip or reverse the bending order, and it will change it back on your main page. And see, now with it in reverse, all of our bends are up high in the air. So you just need to play with that a little bit to work out. It's a good little tool. Up here in the corner you can also see the rotation. But yeah, so that's that. Now the other thing you can do is add some green. We've got cut off at the start, so I know that you need, for my particular bender, I need like 170 mil. Oh, hang on a sec. And I'm back. Sorry about that. Yeah, so sometimes if you've got a bend right near the end of your tube, depending on your bender, for mine, I know I need something like 170 odd. Actually, I think I might even have it in. You can set up warnings, manufacturing warnings, and I'm pretty sure I have done that before. Basically, if you don't have enough green on the end and you go to bend, your tube can pull through the follower die, and that can be a world of hurt, and obviously you won't finish your bend. So when you come across those sorts of situations, in here it's really easy to do. You can go, hey, let's throw on an extra 150 mil, 150 mil of green on the end, or maybe you needed to put it on the other end. You can put 100 mil on that end, and you can see right in here we've got that red showing up, and you would have also seen that now our cut length has extended that additional 250 mil. So you can set it up like I was saying, manufacturing warnings. So if you've got a bend near this end, let me see if I can find one, because I'm pretty sure I've got it set up. So for instance, you'd be surprised, you know, the last thing you want to be doing is bending, and then all of a sudden you go, oh shit, it doesn't work. You know what, that there, that looks like it might have an issue, that one there. So let's have a look. Got a bend right on the end. See here? See how we've got a bend right on the end? So in a couple of cases, so even if you were to pull and see how we're orange up here, there we go, I was right. So we're orange, and then manufacturing warning, and we've got this red. And I've got here bend 1 too short to start. Okay. And basically, not sure if it's auto fixed it. There you go, auto fix. Boom, it's added some green on there. It's what has it added? It's added 49 mil, and now we're green to go. So on your first bend, you need to clamp your tube, you see. So that 49 mil, that's about the width of the clamp. So that's probably where that came from. But these are all things you'll pick up, you know. This is a bit more advanced. but you'll where you've got because because BendTech's really good for really minimizing your wastage on your tubes and your materials. It's really handy to have this. So obviously, once you've done the bend, you'll have to cut that 49mm off, but you know you're going to be doing that. But it's really handy that it's identified that you're going to have a problem before we even go and start. So yeah, that's about all for today. Bit of a BendTech overview. Don't know if it helped anyone. If it did, let me know in the comments. Throw us a follow. If you haven't already, check out the trophy truck build. And yeah, we'll see what other videos we can put out in the future, and so stay tuned. Thanks guys.